So gravel is falling on a conical pile at a rate of 4 meters cubed per hour. So you've got to imagine some sort of gravel company. Here's our gravel, perfectly round conical pile. It probably has some sort of conveyor belt system that's taking the gravel up and dropping it down, and it nicely will form a cone. So this happens with gravel. If you ever have you're working on a farm with grain and you're dumping it in a pile, always makes a perfect cone. Yeah. So now we know that it's falling at a rate of 4 meters cubed per minute. We want to find the rate of change of the height of the pile, find the rate of change of the height of the pile at the moment the height is 3. So we want to find dH dt. This is what we're trying to solve for. So that tells us that height is a function of time. Okay? We're told in this situation that our diameter is always double our height. So our diameter is always 2 times our height in this question for our cone. And we're given that it's falling on it at 4 meters cubed per hour. What rate is that? Well, it's a volume question. Four meters cubed per hour is the change in volume with respect to time. That's telling us also that volume is a function of time. Now, what's the volume of a cone?
What is it? It's circle plus pi. It's circle times 1/3 h over 3.
And he's got it.
So 1/3 pi squared.
Y over 3? Okay, so here we go. Here's our volume. Here's our formula. Again, this is what makes this unit difficult, or this part hard, is coming up with the formula. 1/3 pi r squared times height. Okay? And do you recognize this part of the formula? That's a cylinder. So anytime you have a cylinder, and if you take a cone inside that cylinder, okay, that cone inside that cylinder will be 1/3 the total volume of the cylinder. And that works whether you take a cylinder or whether you take a pyramid, will be 1/3 of whatever the rectangular prism would be. And the formula for the cylinder, the bottom is a circle, okay? And if you just keep piling up circles all the way up the height, you would fill up the whole thing. And that's why the volume formula for a cylinder is pi r squared times height. And anytime you get a cone or a certain point on there, it will be 1/3. And the cool thing is you could move that point anywhere in that circle, and that volume would still, well, be a different kind. It would be a slanted cone. I'm not going to prove it. Okay. So now we've got our formula. Now, we want to take the derivative with respect to time. But what's the problem here is we've got 2 variables on this side. We've got an r and an h. And that means that radius is a function of time too, but we have nothing in here that tells us what dr dt is. So before we go and do this with our formula, take away the black brackets here, before we take our derivative with respect to time, it would sure be nice if we could rewrite this equation with only v and h. And we did this a little bit already with our optimization problems. Remember the can of pop problem? it had height and radius in it, and we changed things. So is there something in this question that would allow us to change? Well, we were told that the diameter was always double the height. And diameter is 2 radiuses, so we know that your radius and your height are always the same. So now we can rewrite this equation and say volume in our particular case, h squared times h will be h cubed. And now let's take the derivative with respect to time of the whole thing. dv dt, the 3 would come out in front, pi h squared dh dt. And we want to find dh dt when the height is 3 meters. So we know that dv dt is 4. H at 3 dh dt will be 4 over 9 pi, and this is meters, and time is measured in hours, meters per hour.
Can you explain again how you got the radius, or you took the derivative of the radius, and how do you equate that to the height?
Okay, at the top here where I figured out the radius was height, this is not derivative, this D stands for diameter, because in the original question here we were told the diameter is always double the height. And diameter is 2 radiuses, so 2 radiuses always double the height. And so that means the radius, 1 radius is always equal to the height. So I find that these questions have a lot of setup. Like, you don't have to write v as a function of time and h as a function of time, but by writing that, that allows you to do what we do here when we take the derivative with respect to time. That's the whole idea of why the implicit differentiation works. If that, and maybe that was explained to me when I learned these, and maybe I just wasn't listening, but I was always confused at why you do this weird derivative thing with implicit differentiation and where that came from. But if you think of those as each variable in this volume formula is also a function of time, even if we don't know what that equation is, it does allow us to take the derivative with respect to time. You like it with the v of t, wow, like this, and the h of t. I can scroll back down.
You said you show off.
So what this answer is telling us is it's telling us when the height is 3 meters of this cone. This is the rate that it's changing per hour. So we could expect it to raise up. This is about 4/30ths of a meter in the next hour. So you would have an idea of, if we left this per hour, how high is our cone going to be? Right? At what point are we going to, right? If you accidentally left this overnight, at what point is there going to be a problem that it goes past the top of where it's spilling and covers it up, and then you can't get your machine out because it's all full, or something breaks on your machine?
Or you know exactly how long you can be negligent.
Yes.
Just use math to figure that out.
How long can I be negligent?
Yeah.
Yes. Nice. Right? And then And then when you get taken to court because you were negligent for too long, oh, I just made a small mental math error, so it really wasn't my fault. Yes. Oh, can do a check how you did here. Here I put in the dv dt as a negative because it's decreasing. So one way that you can show that something's increasing or decreasing is whether it's positive or negative. Well, if you wrote it's decreasing at a rate of 1 centimeter per second, that is the same way it's written in the question. You know, yes, you can't. You don't want to say decreasing and then put the negative number in there. You're actually increasing.
Two wrong to make it right.
So you want to really make this confusing in the end, then you will say it's not decreasing at -1. Oh. Is that double negative decrease? Oh.